In this video, we'll talk about finding the absolute minimum maximum values of functions, which is the same thing as finding the extreme values. This is really what we mean by extreme values is the max and min values of functions, which is really what's the biggest and smallest this function can be on a given interval. So if we have a point f of a, we say this is the absolute maximum value of f on some interval I, if, first of all, a is a point in I, and f of a is bigger than every other value on this interval. So, and f of a is bigger or equal f of x for all x in I. Note that I could take x to be a here, and that's why I would get the equality. But basically I'm saying that f of a is the biggest I can get on this interval. We have a similar definition for the absolute minimum value, just with the inequality going the other way. Right, we say f of b is the absolute minimum value on the interval if b is a point in the interval, and f of b is smaller than or equal to every value on the interval. And together, these absolute max and absolute min make up the extreme values. And you'll sometimes hear these referred to as global extreme values to contrast with local extreme values that we'll talk about later. But these are just the biggest and smallest values this function obtains on this certain interval. So, how can we go about finding these points? Well, as of now, the only trick we really have is to stare at a graph and see what happens. And we'll see examples now of what that might look like. We have a whole bunch of functions here. We want to figure out, does every function have an absolute max or min value on any interval I? And so we'll look at these examples and see what happens here. So if we look at this first example here in the top left, we can see if there's a maximum value right up here at the top, but there's no minimum value. Why is that? Well, the minimum value should be down here in this endpoint. However, that endpoint is not included in my interval. Right, that is an open circle, not a filled-in circle. Therefore, it doesn't attain the minimum value. So while the minimum value should be that number, I don't attain that value because I don't have that value in my domain. We can see the same thing sort of holds for a lot of examples here. For the one over here on the right, for this guy, we have that there's a maximum value again up here, but again, no minimum. Because that point isn't filled in the spot there, it can't be the minimum value because I don't attain that point, right? The point was for my definitions, I had to have f of a be the smallest thing. There's no value in my domain here where applying the function gives me that lower vortex there of that parabola, right? If I plug in 0, I get 0, not minus 1. Therefore, I don't attain the minimum value. Continue on to the next examples. We have a minimum down here and no max because this is not filled in. This has neither. Look at the next function here. Well, now we have both, right? We have a minimum down here at this point. This is a filled-in circle here. And we have the maximum up here on the top left. For these functions here, we see very similar things happening again. Here's the max. Up here is the maximum. And here we have no max because as we go to the endpoint there, the function gets bigger and bigger and bigger. It never stops. So it keeps going forever. There's no maximum value there. And for minimums, we have a minimum here, a min down here, and a min at this endpoint here. So the key thing to take away here is not all functions have maxes and mins on every interval. There are certain conditions that have to be met to make that happen. And if you scroll back those examples, you'll see what those conditions might be. The theorem we get out of this is the following. If f is a continuous function on a closed interval, say from a to b, then f will attain its max and min values on this interval. By that I mean there is a point C such that f of c is the biggest that is on the interval, and there is a point D such that f of d is the smallest on that interval. And that's it. If you go back to the images before, you'll see that the ones where we had maxes and mins were continuous, and the ones where we didn't did not. Now, this doesn't say that the function does not have a max or a min if it's not continuous, but it says that if it is continuous and the interval is closed, then I'm forced to have this max and min achieved. We can see from pictures how to do this graphically. That wasn't too hard to do, but we're going to one analytic technique as well for how to do this just from the function and not having the graph. And that's where the rest of these videos go, is to how do we develop this analytic method for finding the maxes and mins without having the graph to build from.